So we're going to work on this problem, and I'm going to start with the circle and make sure it goes through -4 and -7. I'm going to do it from scratch so that you can see the process a little better. And just make sure you do understand this point is not on the unit circle. Okay? I'll show you, I'll prove it to you that it's not. And this is a common problem. You're going to see it again and again. Make sure you get it. So -4 and -7, I don't have to be exact. I would like to choose the right coordinate, quadrant. Let's just say it's somewhere here. It has to be in the third quadrant, -4, -7. Let's just pretend it's somewhere here. Again, really don't have to be exact. I'm taking my time. I could have easily pulled a picture. Okay, now I need to find the radius of this circle, and the radius is going to be this length. Okay, now this is -7. And just to let you know, my picture is not going to be perfect. This length is -7, and this length is -4. And I'm going to call this R. Now, how do you find the value of R? You use the Pythagorean theorem. You say R squared is equal to -4 squared plus -7 squared. And -4 squared is +16, and -7 squared is +49, and 49 plus 16 is 65. So far, so good. Now, from here, I can conclude R is the square root of 65, and radius is positive, so we consider the positive value, and clearly square root of 65 is more than 1, so we are not on the unit circle. Okay, everything we know about the definition of sine and cosine must be based on the unit circle. So I'm going to draw a smaller circle with the same center, and I'm going to pretend, again, I don't have to be exact, I'm going to pretend this is the unit circle with the same center. Now, I want to know this point, the coordinates of this point. And remember, guys, how we did that? We are going to pretend all of this. We're going to take this big triangle and kind of shrink it. This is the big triangle. And then shrink it to this triangle. Okay? Everything must be divided by square root of 65. If I divide the radius square root of 65 by square root of 65, I get 1. So the radius becomes 1. So this point, I'm going to change the color actually to green. This green point has these, and you really want to pause and reflect and make sure you get it. The coordinates of the green point are yes, you have to put the radical sign. Don't write 65. That would be incorrect. So the coordinates of the green point are as follows. Okay, guys, This is a very important concept. You really want to understand it. All right, you're going to see this problem again and again. Now, based on this, I can easily find sine and cosine. Okay, so let me see what I can do. I don't think I need this. I'm going to delete it. Now, I'm going to apply a trick so that I don't have to mess with this picture too much. I'm going to take a screenshot. Okay, now, so far so good, hopefully. Now, I'm going to list things here all over the place, I guess. My sine theta is the y coordinate. Okay. Cosine theta is the x coordinate. And let's put these guys here. Okay. I need the room. All right. I got two of them. Secant is simply the reciprocal of cosine. So that's something I can handle with. Secant theta is the reciprocal of cosine. Actually, I'm going to put it here so that I can see them better. Secant is the reciprocal of cosine. That'll make it and don't mess up here. And cosecant is the reciprocal of sine. Cosecant is the reciprocal of sine. So I have four of them, and they were relatively easy, right? Now, how do we find tan theta and cotangent theta? Let me do it in detail. Tan theta is sine over cosine. Tan theta is sine theta over cosine theta. Now, sine theta, you can write, well, let's write it down. 7. I know some of our friends / students are still struggling with this. This one, you really have to get it because you're going to see it over and over again. Sine over cosine. Okay, almost done, guys. Almost done. If you do your flip and multiply, this minus sign and this minus sign will cancel, and this will cancel with this. So you're going to be left with 7 over 4. Do it. And at this point, you know how to do it. Positive 7 over 4. Done. That's my tan value. And cotangent theta, of course, you can do it from scratch like we did. You can say cotangent theta is cosine over sine. Why would you waste your time? You can just say 4 over reciprocal of tan, 4 over 7. We have them all. We have all the answers right here. Let's highlight the answers. These are my answers. And I just wanted to show you that you can do things from scratch, and it really doesn't take that long if you know what you're talking about. Okay.